from Saskatchewan.
That's me. This might be why I was the speaker, not him, because it wasn't detecting his voice.
Richard, can you hear me now? Okay, awesome. Thank you. I just want to say thanks to Dr. Paranjpe. I want to say I'm a student of University of Regina. I did my Master's in Engineering and MBA from UFR. I'm standing here. I think about the days I was a student, and Dr. Paranjpe was one of my profs too, and he's been a big help during the time. I want to be very honest. I'm not the best student. I'm not the smartest student, but the professors like Dr. Paranjpe and the University of Regina really helped me to who I am today. I want to thank University of Regina for making my life better and where I am today. Thank you. Thank you, Dr. Paranjpe and Faculty of Engineering. On PTRC, we have been here for last 25 years. We just recently celebrated 25th anniversary, day before yesterday. We had a great participation from University of Regina, profs and President Jeff. And I just want to say the collaboration between PTRC and the University of Regina goes a long way. I think, I was speaking other day, I was saying that the University of Regina is best kept secret, not anymore, because the work has done here is a really phenomenal work. I think people say it's a small university in Saskatchewan, blah, blah, but if you look at the work, especially done in CCUS, carbon capture, utilization, and storage, the research of CCUS started in 1996 in the University of Regina. And not only that, they have other programs like that, solar and the microgrid and everything they're working on. All these things are very important. When I want to tell people is when it comes to energy, you have to think like a mixed fried rice. You cannot say there is one energy going to fit the ball, like one energy going to fit the bill. You have to say you need solar, you need wind, you need geothermal, you need carbon capture, utilization, and storage. Even we are looking at the compressed air energy storage. We recently funded $125,000 on a blue hydrogen research with the CCUS with the Faculty of Engineering. So when you look at all these aspects, what's happening today is very important, because I think the universities and the people and the industry like SaskPower and City of Regina, we are doing work with the City of Regina and geothermal, and SaskPower is a big client of us, especially on the carbon capture. All the aspects are very important to work together to make this decarbonization happen. I don't think one person or one team or one can do it. I think this collaborative effort and symposium are very important to make this happen. I just want to say thank you for inviting me, Dr. Paranjpe and the team, and I'm looking forward to the symposium today. Thank you.
Okay. Yeah. Okay. So our next speaker, or our first speaker, is Wyatt Baker, who's a professional engineer, a senior engineer with the City of Regina's Land, Real Estate, and Facilities Department. He manages several projects, including rooftop solar, photovoltaic systems, charging infrastructure for battery electric bus fleets rollout, and energy and sustainability framework implementation for the City of Regina. So with that, I hand it over to Wyatt. Thanks.
Thank you. I'd like to say other glowing things about the University of Regina. It's engineering department, but I actually came from the University of British Columbia, so don't hold that against me. So yeah, I'm Wyatt Baker. I'm a senior engineer with the Land, Real Estate and Facilities Department. And our corporate communications folks did not approve of this slideshow or have any input whatsoever. So forgive me if it's a bit high school in the layout. So I was asked to put together a presentation of what the city is doing for renewable energy, specifically, not just solar and battery storage. But as you'll see, most of what we've done so far is solar. So we'll talk about that and a few other things that we've been doing for renewable energy in general. So we'll touch on rooftop solar and other future considerations for the city. So what has the city been doing for solar? We've effectively tried to say, hey, if we're going in to replace the roof, let's replace the roof and put solar on right afterwards. It's not cost effective at all to install solar on an aging roof because eventually 10 years plus, you'll have to replace that roof. You're gonna have to take the whole solar system off, redo the roof, and then put the solar system back on. So as we're going through with our roof retrofits over the past few years, we've put solar panels up top. In addition, any new buildings going forward, we're going to put solar up on the new buildings. Currently, we don't have any battery backup systems in place. We found that the batteries are just not cost effective yet, but hopefully those costs will come down. So we're still using the SaskPower grid as kind of the battery at night. So we currently have 5 installations generating a total peak of 186 kilowatts and another 2 extra installations wrapping up this year for an extra 56 kilowatts. So we'll just go over a few of the projects here. Maple Leaf Pool was our first solar photovoltaic system, just off 14th Avenue by the hospital. Picture on the left there is the old pool that was built in 1940-ish. That was demolished and a new pool and facilities built right next to it. So you'll see the panels right there. Most of our installations are these low slope solar arrays. We found that they're cheaper racking, but as soon as you get up past a certain angle or height above the roof, then there's extra wind loads and then potentially extra reinforcements to the structure of the facility. So the Maple Leaf Pool actually has no anchors into the building itself, so it doesn't penetrate the roof membrane, and so no leak path. It's all just self-ballasted with these deck blocks that you'll see. That same year, over at the Glencairn Neighborhood Center, this is an example of us going in and replacing a roof. This roof was over 30 years old, and we tore that off, put up a new EPDM membrane roof, and put solar panels up at the same time. So with both these projects in 2020 were done before the Energy and Sustainability Framework were approved and without any dedicated funding for those endeavors. They were mostly kind of below the line item additions that we snuck into the budget. A couple other pictures of the Glencairn Center. You'll see even in the winter with the black color of the panels, lots of the snow melts off. But after a heavy snowfall, we might need to plow them with the snow shovel. Fast forward a few years, the ESF is approved. We have some more funding now for some projects. So here's a picture of the Wisconsin pool. My microphone. So you'll see the old pool on the left that was demolished and a brand new pool put in on the right and solar panels put up on the brand new roof. This is a 40 kilowatt system. Another example of a re-and-re, Fire Station 7 was just done through 2022 and 23. Again, taken off the old roof, and we put solar panels up over the apparatus bay, and 2 of the lower roof sections got some solar panels. The one on the south had too much shading from trees, so we opted not to do that there. Regina Police Service recently finished a major expansion where we purchased the old STC building, a headquarters, turned that into police offices, and we built a building in the middle of the two headquarters. And since this was a new build, we put some solar panels on top. Again, that's another 40 kilowatt system. With all these systems, we have ongoing monitoring. This is just a picture of the Solar Edge monitoring platform. Most of our facilities are using Solar Edge inverters, and we found that with that, you have the option of having power optimizers on every panel, and you can actually look at the performance of every panel. Some other vendors we've found, Wisconsin, for instance, got a cheaper inverter and has absolutely no ability to look at the panel performance. So if something goes wrong, you're gonna have to test every single panel. So that's something that we're finding out as we implement these projects. Just some high level costing on a few of our projects. You'll see here that the cost per kilowatt has been pretty standard between $2,000 and $2,500 per kilowatt. And I grabbed this chart, I think from an International Energy Association study on larger scale power plants, solar voltaic. It's pretty hard to see from the audience, but solar PV power plants are about $1,400 per kilowatt. That averages out to $2,000 Canadian. Just for comparison's sake, for a renewable grid combined cycle gas plant with a percentage of carbon capture and storage is about 3,000 US. Obviously, non-carbon capture storage plants are still the cheapest thing there is, capital cost wise. So a few limitations we found. Obviously, most people know that SaskPower limits the PV systems to 100 kilowatts that are tied into the grid. Lots of commercial clients and industrial and the city have rooftops that could handle much larger systems than 100 kilowatts. For example, the Al Ritchie Arena could fit 350 kilowatts of panels on its south slope. So if we were to do that project, we'd have to have significant energy storage just to allow us to store that energy, because the net meter that SaskPower put in would limit the output to 100 kilowatts. Another hidden cost on those projects, SaskPower would have to complete an interconnection study on all systems that are larger than 100 kilowatts. So it's just an extra cost in your planning. Other renewable energy projects we've done over the past decade, Fire Station 4, this is actually our first solar panels at the city, but they're solar thermal water panels. This was done on a LEED project on the brand new Fire Station 4 on Dewdney Avenue. So these evacuated tube solar panels preheat water to the hot water tank in the facility, which provides domestic hot water and some radiant space heating. I guess one lessons learned on this is to get effective buy-in from your operators. This system sprung a leak a few years after commissioning, and they just drained the system and said, "You don't want to deal with this." So I finally got this recommissioned this year, and it's operating again. Landfill gas in 2017, we purchased an engine to burn off methane emissions from the landfill and turn that into electricity. So if we didn't do that, just rogue methane emissions would be escaping to the atmosphere anyway. So this has generated over close to 6,000 megawatt hours last year. Also, west of the city, at the new wastewater treatment plant, methane is actually captured from the fermenter and is fed back and burned in the bioreactor, which offsets natural gas use. So that have offset the equivalent of 8,000 megawatt hours last year. So future plans. Obviously, this is with the caveat of if funding is approved on every budget cycle. But I did a quick count last week, and the city has over 1.5 million square foot of rooftop space at city-owned facilities. And that's not not including real or some of our wastewater facilities. So assuming 50% of that is suitable for solar power, that's about 15 megawatts of solar PV that we can have distributed around the city. At about $2,000 kilowatts, that's only $30 million, but if we spread that over 20 years, it's just over $1 million. So with roofs having a life expectancy between 20 to 30 years, conceivably every roof in the city will have the opportunity for solar panels before 2050. Other things we need to look at, city has some unused land that we own around the city, so we should start looking at that for the potential at larger solar installations. I've just highlighted one here north of our transit operations center. It's land that was given or bought on the cheap from Imperial. It's contaminated land, has no use, so might as well put solar there. Obviously, for larger installations, we need to cooperate with SaskPower just to allow us to feed that much power into the grid, or we just wait for the next call for an independent power producer agreement. But this would effectively make the city a power producer again, kind of bringing back the old Regina Light and Power. Geothermal heat, as was touched on earlier, we're looking into moving forward a design for a deep well geothermal installation to provide heat for a brand new indoor aquatic facility. This facility will replace the current Lawson pool, and it'll go down two kilometers down the surface, tap into the Deadwood aquifer. It will extract the water from that. We'll run it through a heat exchanger to capture the heat, which will then heat the pool water. And then once the heat's recovered, the water will be fed back into the Deadwood aquifer at a different point, so you're not short-circuiting the fluid and losing all your heat. There is potential for a kind of a larger district heating area from this, because there's a lot of latent heat in that water. Also on the geo theme, but geo exchange or ground source heat pumps, we're going to start looking at this a bit closer. So effectively, that's not renewable energy, but it's using the earth as a long-term thermal storage, kind of just a large solar thermal mass down there. But the way that renewable energy ties into this is, I think a few experts are saying that in our climate, you can't just have a ground source heat pump grid and draw from it in the winter if you don't balance it in the summer. So one method of balancing it is using air conditioners, put the heat back in the ground, or use solar thermal panels on your rooftops to heat up the water from the sun and then pump that back to the ground. That'll keep your geogrid balanced, and you'll have the ability to still continue to draw heat in the winter. We had one consultant look at doing the system across all of our facilities. That's why there's quite a large capital cost here of $140 million to retrofit all of our facilities for a ground source heat pump. But I put this graph here because it's interesting. So ground source heat pumps will have a very low operating cost, but compare that to air source heat pumps, have a lower capital cost, a bit higher operating cost because you will have to top up your heat from your air source heat pump with probably electric boiler. Or there's the opportunity to retrofit our heating systems with just electric boilers, which I know SaskPower will cringe at the large load that will take. But from a CapEx perspective for the city, it's the least costly, but the highest operating cost. However, all three of these systems kind of equate at the end of a 25-year life cycle. So there's no silver bullets on how we're going to decarbonize our heating systems. It will kind of be a case-by-case basis. Probably on a new build, ground source heat pumps might be the most cost-effective because you're you're in the earth anyway with your foundations. What's drilling a few extra holes next to your piles. But again, we're looking into this technology for our buildings. And finally, microgrids. So we're currently in the detailed design phase of bringing in some charging infrastructure. We're going to electrify our entire transit fleet with battery electric buses. So to do that, we need at least a peak power load of 10 megawatts being brought into our transit op center. And that's quite costly. SaskPower can't just turn a switch and give us 10 megawatts right at our curb. They'll need to bring in extra transmission lines, and that's quite costly for the customer, and the city in this case. So what we're looking at is trying to reduce this peak, supplementing it with a mix of solar on the roof or on that land to the north of the op center, and quite a lot of battery storage to store that power during the day and then off-put it or discharge it in the evening. And then the battery storage would also just hedge against any power outages from the grid so that we can still charge buses. The alternative to battery storage would be installing 10 megawatts of natural gas generators on the site, but that's far from green. So some interesting projects that we're looking at. Aside from our facilities that we control, just one slide here on what the city is looking at doing to encourage the growth of solar PV in the community. So we're currently doing a feasibility study on property assessed clean energy programs, or PACE. These programs are done across North America. So the intent would be for the homeowner the ability to give the homeowner a loan that's tied to the property for them to fund the solar installation. And then the loan is paid back annually through property taxes. But the good thing is that this debt stays on the property if the house is sold. So it helps offset the large initial cost of the system, but it also removes the what if the homeowners aren't sure of, how long they're going to be at their house and the impact to your resale value of the home. We're hoping this will be available to homeowners in 2025, 2026. Just on a personal note, a few years ago, I was looking at getting a PV system on my rooftop before the SaskPower change in the net metering program. But I ended up moving a few years after. So who knows what those solar panels would have done if I would have recouped all the capital cost on my resale value. It's always the unknown. So we're hoping the PACE program will really kick off a huge boom in PV on our residential roofs. And that's it for my slide deck. Is there any questions? No.
I'm curious about how the city might impact the development industry with new land development, taking when that kind of gets kickstarted again, and the idea of building renewables into those zoning applications and such. Are you having discussions about that? Maybe why?
Yeah. Just clarification: commercial, industrial, residential, any type of development.
Thinking primarily residential, but it could be anything.
Okay. So the question was, how can the city help encourage, I guess, renewable energy development on new zoning applications or building permits? I'm not having those discussions because I'm just in the facilities department doing projects. I'm not sure if Robbie, if you know of any of those. I think the PACE program will help that. Ultimately, the building codes will dictate the minimum standards on development, and the Sask government is bringing in the latest NECB in January at the step 1, and potentially going up future steps in future years. So that will help at least set the minimum baseline. I don't think there's any appetite from our building code group of going more stringent than that. It might push development outside of the city to.
Doing the way tax abatements or tax holidays for a certain number of years, just like we do on densification projects.
Yeah, potentially. Any other questions?
Are you looking into the new technology used on an experimental basis called sand batteries, where they're just sand in a silo and they heat it up and they heat up maybe?
The question was if we're looking into other technologies like sand batteries, where it heats up the sand and takes out the heat and puts it into electricity. I haven't seen that myself. For the transit projects, I was looking into vanadium flow batteries, which is similar. It's different technology than lithium ion. But talking to the sales guy, I didn't think it was the best use case for that. Okay. No, I haven't looked into that. It's similar to kind of ice storage in California that they do for air conditioning. Yeah, it's potential. I haven't come across that yet. Yep. One more question in the back.
So if the what other factors do you consider, like consider the rating code in that facility, consider location, like just maybe expand on why you selected those buildings.
Yeah, no, the question was why those specific facilities were focused on solar, and if we considered any other factors. So just off the top, we're doing a whole range of projects to meet our 2050 goals beyond just renewable energy. So we're looking at building envelope and energy efficiency projects. I was just focusing on energy specifically. But for the locations, at least in 2020, those projects were off the ground anyway, and then we just tacked on solar. And as the roofs expire in age, we have a good program where we look at condition assessments of all of our facilities, and that tells us when we should plan for a roof renewal. So at that point, we're renewing the roof. Let's put some solar up. Obviously, if it's not a good candidate, if it's not a good slope, if there's trees in the way, we're not going to just put panels up for the sake of doing that if there's no good feasibility there. Yep. Thank you.
Okay. So our next speaker is Doug Wagner. Doug is a instructor in electronic systems engineering at the University of Regina. Doug's main interests are in terms of teaching analog electronics, analog design, energy and power, geared towards electronic students, power quality, industrial electrical protection and coordination. So I think with that, I'll hand it over to Doug. Did you get a memo? I've got it.
Getting some problems with your file. Let's try it with the browser.
Sure. Yeah, you wanna,
What do we do if we,
you have it, you download it from someone's email, or that didn't work?
it didn't because it's too large. Okay, what happens if I plug in to the HDMI? We lose the Zoom
We'll
people?
lose the Zoom, but that's okay. So we can add that later.
Okay,
We can figure this out.
okay, really sorry about this. Not good with technology. How long can I get away with that, Joe? It's over here at laptop. They warned me in engineering, you should not work with Macs, and I work with Macs. There we go.
I
Yeah.
see it there.
Yeah. Thanks, everyone. Sorry about that. So, and maybe I will make sure I start at the first slide. Yeah.
If you want to stand in front of this, at least we'll have you.
Okay. So again, the title was a little fluid for this symposium, but I'd like to just talk about enabling solar and microgrid storage in Saskatchewan, talk about small and not so small microgrids. So I'd like to just, I was given a pretty good introduction, but I always like to embellish and give a bit of an overview of a small microgrid system. Talk about storage and batteries within the context that I'm going to set up for this. And then I'm going to throw out some ideas in terms of how microgrids might be able to lead us towards decarbonization and reducing energy. A lot of times at events like this, everyone is excessively polite. And either at the end or during the plenary or during the social after, I'm really happy if someone comes up to me and says, why the heck did you do that? Please don't hold back on those questions if you can. So again, my name is Doug Wagner. I'm an instructor. At one time, they used to let me go by the name engineer in residence. Why am I here? Well, along with my wife, I'm the co-owner of a solar microgrid. So we'll talk about what actually makes it a microgrid. And this is actually a 4-phase project that started in 2017. And I'm also part of the University of Regina microgrid team. So there is also an initiative which was funded through Prairie Scan. It's led by Dr. Irfanel and Baggy, but has a team and is really an open research platform that's going to be commissioned later this year. So some of the things you hear about when I present a small microgrid system, if you're saying, well, could you go further with that? Could you try that out? In a research environment, that's actually something that's possible. I've been in school a long time. And have a variety of jobs outside of the university environment. I'm currently actually trying to see if I can practice what I teach. So I'm working on sabbatical with an electrical services and engineering firm here in Saskatchewan. So what is a microgrid? Again, textbook explanation here given, I guess. But of course, Wikipedia has an answer for us. Sometimes better to look for an actual IEEE standard. But in its essence, we're looking at a system where we have some form of generation, ideally renewable, but not necessarily. We have loads, and oftentimes those loads can be curtailed, load shedded, the essential loads, non-essential loads. And we have a method of disconnecting from the utility. It's not a standalone, hey, goodbye utility. We're existing in harmony with the utility, but we can operate in what's called an islanded mode. That can either be forced upon us or that can be chosen for a variety of reasons. And that's what defines. Now you might say, well, what if I'm like a hospital and I have a generator, or the university we have a generator? The difference is it's generally not economically viable to be operating on that generator. In the case of microgrids, there is an economics or a social economic benefit that comes into play. So let's talk about the microgrid system that I'd like to focus on. But again, I want to emphasize that this system is one representative value, and what's happened in this system can be expanded, can be researched upon. I often, when people talk to me, they say, I say I'm an instructor, I teach. I don't do research. And then I met some people in the Faculty of Education in Saskatchewan who said, well, no, what you like is you like action research or applied research. You like to try something and see if it works. And that's great, but it's expensive. So if your significant other will let you get away with it, that's great. But not everything we've tried has worked. So our system evolved, was originally grid tied. We were under the initial SaskPower net metering program. And then the discussion came up, which was that, hey, it'd be nice to have power when SaskPower isn't there. Well, should we put a generator in? So we did an economic analysis, an environmental analysis, honest. And it turned out with our system, actually putting in storage was the most long-term economically and socially acceptable solution for us. So we added one battery and some additional panels. We also knew when we did this that this would shift us from the 1-to-1 net metering arrangement that SaskPower has to essentially it's a 1-for-2 or a 50% feed-in tariff. And we were okay with that because we thought the battery was going to help us leverage that. And how this is actually playing out, we're actually still not sure. A lot of people will, just to digress, a lot of people will point to that change in SaskPower's policy as being, something that was damaging to the solar industry. And I have friends who work in that industry, and it did impact them. But SaskPower is not alone if you go across North America. For instance, if you follow what's happening in California, they're on their third iteration of net metering. And their first iteration was a feed-in tariff, similar to what Ontario initially did. Then they were very close to the initial SaskPower proposal. And now they're in a proposal that's a little more punitive than SaskPower's for net meter. And you could argue that really what they want you to do is put in storage, is how they've geared this. But back to the diagram that I have up here, you can see we have SaskPower present. We have a main breaker panel. We do not have a full home microgrid. There are a couple of ways you can do that. We did that by rewiring our service entrance and putting in an essential panel. So you can think of the essential panel as critical loads or non-curtailable loads, and our other panels. Basically, the things that are not essential in our house are the stove, the dryer, the air conditioner, which is now also our heat source, one of our heat sources. So there's a number of ways we look at that. And then we have a significant amount of storage that's present as well. It started as one battery and it grew into three, really. It started as three, grew into 5. So we have those batteries. We have a device in there called a microgrid interface device as well, that MID. And that's actually a critical element to what is involved in microgrids. There's a lot of control and there's a lot of interfacing that's required. So looking at this system, it's again, roughly 9 kilowatts of power if the sun's hitting all the panels at once, which it never does. Some of them are inaccessible from the ground. I'm kind of a frightened fellow. I don't like to climb ladders up too high. So basically on this snow, we've lost a lot of production until it warms up again. Some of the panels are set up explicitly so they can be cleared in the winter. So we always have a source of power. Our basement looks more like a mechanical room now. We have a number of elements that are involved here. We have a gateway, which I'll talk about in a little more detail, but it's essentially the interface between the control of our system and a supervisory control. Basically allows data to go out somewhere. We have a device that we didn't really need, but is really critical to our system, which is a real-time monitor. It's not marketed by any of the people who are vendors of this equipment, but essentially it's monitoring whatever loads we choose in real time. Then we have our essential panel, our main panel, and we have our MID device, and then the NFT. It's not a non-fungible token. I wish I could get millions of dollars for it. It's a neutral forming transformer, so it's required by the electrical system because we generate 240 volts. We do not generate 240 with a reference to neutral or to ground. So we have to add that in when we island. And then these are our batteries in our garage. So basically the large battery that you see there on the left is 3 of the smaller the large battery you see on the right. I don't remember my left from right. The large battery on the right is 3 of the other batteries, which you see on the left. So they're mounted in our garage. And in terms of battery chemistry, which I'll talk about a little more, these are lithium iron phosphate. So there was a whole process that we went through in determining what type of battery. We went through this on our vendors for our inverter technology, for our battery technology and battery chemistry, and it was a big deal, which I'll talk about a little later, that we settled on this technology. So our system, as it stands, as it's doing right now, can operate, it's a solar with battery system. If we had the solar only, we only had one option with the technology we had, and that was we could produce energy when SaskPower was present. When SaskPower wasn't there, we were required by code, by SaskPower, to disconnect. The regulations are a bit confusing. Some of them will say you have as much as 1 second, but generally they want to have you off in 100 milliseconds if SaskPower is not present. They don't want you backfeeding the grid. Some solar-only systems have the capability of forming an island but obviously only when the sun is shining, if there's photovoltaic or if the wind is blowing. And it's not trivial. If you eliminate the storage problem, you face a problem that the utilities are well aware of, that you have to match your generation to your loads. If you have a lot of generation and not a lot of load, then you have an issue. You're going to get voltages rising, or you have to do something actively to dump that excess power that you're generating. So solar only microgrids are still, I think they're a bit dicey. With storage, we have a number of modes that we operate. We're tied into the grid. So as a solar only system would be, we can island. So we can be islanded with our non-curtailable loads. We can minimize our consumption. So that means we make a choice on when we're going to charge our battery up for later use. Or we could follow an economic rate. So if you think of it, you have two modes that you can consider. Do I want to minimize the amount of energy that I'm drawing from the grid, or do I want to minimize my cost? And that becomes really important when we talk about how we incentivize microgrids from the utility standpoint coming on. Just quickly, I mean, how the system presents itself, how you make these choices, you make them on apps. They can either be on a computer or they can be on a cell phone. And it lets you set things like, what does it cost me to import electricity? What do I get when I export electricity? Is it the same price or is it different? Is it a feed-in tariff? Do I get more or less? Is it an actual economic value or is it net metering? We can also enter in the times of use, that if we have variable rates, which currently are not available at a small scale here in Saskatchewan, there is one time of use rate for large industrial customers. And we can set a number of things. We can pick, do I want to, again, here's where I would pick, do I want to minimize my energy, or based on the information that I provided to the system? Again, this is from one vendor. It's just representative of one vendor, what the typical small industrial residential customer can have as an option. I can either minimize my energy or I can minimize my cost. And I can also decide if I want to run in a full backup mode. If I know a storm's coming, and this is something that this particular vendor markets in the States. They tie into the National Weather Service in the States. If they get a weather alert for an area, it immediately says, charge your battery to 100%. We don't care where you do it from, because you might be out of power for a while. Again, from a residential standpoint, that's great. So from an operational standpoint, it appears like we have access to this particular system right there. And we do. Some of that control is very localized. Some of it is automated within the system. For instance, if we have to force island, if we lose the utility, we have to disconnect any ability to feedback. That has to happen very quickly. So that's an automated response. Other functions, like if I want to change my mode from self-consumption to full backup, I actually make that request to the cloud, and that comes back from, in this case, it's either Idaho or California, fairly quickly, but it's actually verified or validated through there. Might say that sounds terrible, and I actually don't like it, but it was the cost of having a system that we could present to the design review group that they would recognize as being from a reputable vendor. So for instance, in the university system we have, those are all decisions that we can make with our localized controller, which is much more sophisticated than this, but that's how that is done. So in addition to the electrical aspects of this system, there's a lot of communication. This diagram has been simplified since a previous talk I gave, but we actually are communicating over power lines. So within our house, we're sending data via power line carrier. We're sending it via an Ethernet connection to the World Wide Web. We're connecting then by another wireless protocol throughout our house to the devices. It works. I wish it was simplified, but it works. Like I said at the outset, I'm not good with technical things, but we have our system operating in our house. So that's kind of background. What's it actually doing? Well, right now, today, there's a lot of snow on the panels. So it's not doing, it is doing something, but it's not doing a lot. This is perhaps a more representative graph of what the system did about a week ago. So we basically, this is a snapshot of our real-time monitoring back from a few days. So we're seeing that basically, if you see an area of pink, that's energy imported from the utility. See an area of green, that's energy exported to the utility. And the goal of this system is to minimize both right now. That's the way it's set. And so there was a period of time until about 3 o'clock in the morning, which is, you don't have a pointer to show, but there is a point of about 3 o'clock in the morning where basically the battery was providing power to the house. It provided everything through that evening. And then 3 o'clock, a big load came on. A plug-in hybrid electric vehicle started charging. And then a heat pump kicked in at 4:30 in the morning. So it started to deplete the battery fairly quickly. And then by 5 o'clock in the morning, the battery wasn't depleted. The battery was at a reserve that it holds in case there's an outage. Because one of the economic arguments for this system, or one of the socioeconomic arguments of the owners, is they wanted to have backup power. So then it's basically saying, no more, switch to the grid's there, fine. So then now in that pink area, it's drawing from the grid. And then at about 6 o'clock in the morning, the solar panels lit up. So the solar started producing in the green line. So it basically, you'll see there's just a solid green line with no green area, no pink area. So what it's doing is saying anything that's left over from matching your loads charges the battery. And the battery charged up till about 2:30 in the afternoon. And then it said, now we can export. So now we can give back SaskPower energy, get a credit. Don't know if SaskPower wanted us to do that or not, whether they really could benefit. And that's, again, one of the challenges that's presented with this is it's good for the operator, but maybe not good for the utility. One of the things before we leave this slide that I just want people to notice, if you could, notice the variation. I mean, that date, that was October 19th. Probably nobody remembers October 19th. It was a pretty sunny day, but there was the odd cloud that cruised over on that day. So it is important when we start thinking about what are the impacts of, when we have large solar farms, how rapidly that energy source can change. The difference between a cloud going overhead, we may just minorly notice it, but in terms of energy production, it can be very dramatic. So when this symposium was originally being planned, there was this slot was going to be shared by Dr. Wong and myself, and he was going to, I think, focus more in on storage. So I did want to just talk about storage. Originally it was batteries, but I want to really change the topic or adjust it a little to storage. So when we think about storage on the grid, storage of electrical energy, I mean, it's actually been going on for a long time in one form or another. Like for a large scale, for utilities, the concept of what's called pump storage, the idea that if we have excess energy, we're going to store it in another potential energy source. Probably best example of that is actually the Adam Beck power plant in Niagara Falls, where they divert water so they can not have the falls run dry to generate electricity. It's technically not pure pump storage, but the same technology. We can store for electrical generation thermal energy. So we can store it as molten salt. There's a solar thermal plant in Nevada called Solar One, where they're able to do this. And again, it's to smooth out that curve. So we can generate our electrical energy using a turbine cycle. There are grid level batteries. If you drive out near the landfill, SaskPower has a number of CCANs set out there, which are a new grid level battery going in there. And then there's also the technology to store electrical energy at a large scale level using flywheels, using the inertia of rotating discs in a vacuum sunk in the ground. And there's a couple of large facilities like this in northeastern United States. And again, they're really only there to provide about 30 seconds to a couple of minutes of energy, so you can ramp up another source to cover a variation. When I use the word medium scale, I'm talking about someplace like the university here as being an institutional or an industrial customer. Well, one of the storage methods, if you're using that electrical energy to generate heat or cooling, can you store that heating or cooling at a different time, or draw it when you have excess energy, or it's more conducive for the grid to provide it? And again, that was mentioned on the earlier talk, like that's a technology, ice storage, that's been used in the United States. It's a technology that perhaps has more use, particularly in the heating storage mode in a climate like ours. There's chemical batteries. And then while it's not really storage, there's the idea, can I shift, if I have automated processes, do I have to do them right now? Or can I do them when there's energy available? Then at the small scale, the system that we're talking about here today, again, we have chemical and we have different battery technologies. And then also, could we do the same thing with thermal chilled heated water? So in terms of battery chemistry, when we first started this project, I was going to buy sealed lead acid batteries, build my own system. This came from the farm, seemed to make sense to me. Old tractor batteries work really good in the basement. My wife won't mind. Learned real fast. I kind of knew this before, but despite them being very low cost, they have a real problem in a grid application, because you basically can't discharge them over the full range of their capacity very long before they fail. So they have a very poor operating life. So then there's lithium polymers, the batteries that are in most of our portable devices, in a lot of EVs. And they have really good performance of being able to fully charge them and take them down to a very low level. They're high density, but there are, I don't think it's just an opinion, there are safety concerns with this technology, and whether you want to mitigate that in a long-term installation. So then there's this technology, lithium iron phosphate. So it's pretty good, not as good as lithium ion in a lot of cases. It's a little less dense, energy dense. It's safer though. It will not have the same unextinguishable fire. So it's arguably a really good choice for stationary use. It was mentioned again in the Regina talk by Wyatt, but the idea of flow batteries as well is something that we're not really up on here in Canada. It has some interesting opportunities, because one of the things a lot of these batteries use is vanadium. I think I pronounced that right, which is also a material which comes out of the oil sands. It's a byproduct. So we might actually have a market to support this. The work that's going on in this, the most of it that I'm aware of is actually in Australia. So Australia is where they have the commercially available flow batteries that they're marketing. One problem is they have to be kept above a freezing temperature for the electrolyte. So that presents some challenges. And there may be others. There's sodium-based batteries that are being developed, but there is technology that exists there. It's expensive. So now I'm gonna sort of hope I get a discussion going at some point later on here. So the question is, how do microgrids add value to this decarbonization problem? So obviously, if we're operating where we're trying to minimize our energy consumption, that's for every kilowatt hour that we're not drawing from the grid. In theory, that's a kilowatt hour that's not consuming, producing carbon to produce. And I also will admit fully that that's naive, because if you're the utility, you have to operate according to what your grid requires, and going from 90% to 70% on some generation sources isn't going to make a difference on their carbon output. So I can feel good about that, but I'm not sure that that's not where I would like to see this technology or these systems stop evolving. It can really change. It can really impact the economics of some technologies, things like heat pumps. We're new owners of a heat pump. We're still trying to get the bugs worked out of it. But part of the justification is, on a cost basis, not necessarily a carbon basis, but a cost basis. Without our own generation, you lose the economic argument right now. but you gain the economic argument in a situation such as this microgrid. It also allows for tracking things like, in addition to minimum consumption, tracking tracking the economics of the grid if it's represented in a time of use tariff. So if you're the utility though, what good are microgrids to you? So if you can use initiatives that are created with microgrids, and this is tied into another point I have slides coming up. But if you create a community of microgrids and part of the community is also supporting other areas, other microgrid development, there are areas in the province that really do need microgrids, much more than Regina needed our particular facility. There are areas where there are targets to improve service reliability that are enforced by Canadian Electrical Association. And those are the areas where I think if Sask Power were here, or would say that's where you actually want microgrids. You don't want them in the big cities. You want them in, points north. You want it in Stony Rapids. Well, how does the microgrid and enthusiasm in southern Saskatchewan support those microgrids? And we have to figure out a way to do that. A number of years ago, I was on a call with some people from Sask Power, and one of the points that was raised is that before we go into this area, we need visibility of what the distribution system is doing for the utility. We know what the transmission system does, but do we know what distribution is doing? Do you know what every substation, what streets are drawing? Well, actually, microgrids can provide that. They can actually provide that information, so you can get near real-time data, and that could be valuable. Now, if you have enough microgrids in an area, and you can influence what they do, they can actually support demand management. You can say, hey, I need you to be able to support the grid in the wintertime at, from 4 till 7 p.m. We want to see as much as we can support, or as much decreased demand as possible. If you have enough smart systems, they can, in an area, support the grid. That can also give the utility more dispatch time. That can, so in an ideal scenario, if microgrid battery reserve could count as spinning reserve, that could actually reduce the carbon costs of fuels that are supporting generation. Now, how do we do that? It's non-trivial. And then we can further how do we further this dispatchability of microgrids? Well, one way to do that is through tariffs. Not real tariffs, but artificial tariffs. You have a microgrid community, you say, here is the microgrid tariff you program into your system. So it says your highest value for energy in the wintertime for this particular microgrid might be from 4 to 4:30 in the afternoon. My neighbors, or the neighbors of this microgrid, it might be from 4:30 to 5. But during that time, theoretically, it looks like the energy is worth more money. Practice, it's not. There's no changing of money. But it allows the system then to follow that demand. Now, to do that, you also have to audit that, and you have to incentivize that. So I'm throwing out a lot of things that I'm hoping people will say, what are you thinking? Are you thinking? So kind of to wrap that up, the economics alone do not support microgrids. As you mentioned, my costs are a little different. We used a different type of inverter. We're counting a lot of work on the roof, a lot of wiring infrastructure, and it's a smaller system. It's 9 kilowatts as opposed to, what were they, 25, 50, 40. So I pulled some numbers out that it was about $5,000 a kilowatt for our overall system. Part of the problem is we didn't do it all at once too. We've had to change inverters a couple of times just to track with the newer system. And then to put in the battery, I would say it was, incremental cost over that was probably, $3,000 to $4,000 more. But there can be one of the opportunities we have is enthusiasm. people don't do this just on payback. They do it because they want to feel that they can contribute. They want to, I mean, my dad grew up on a farm where they had a 32-volt wind charger, they had battery storage, they had their own microgrid, and they had that because there was no Sask Power. And it wasn't that long ago that we had a sense of ownership of the utility. We kind of are owners of Sask Power too. It's just a long trail through a lot of people, but you know, we are part of this. We're part of the solution to this problem. There are all sorts of reasons why people would do it. An opportunity, again, is to see if there's a way somehow to identify, I call it a Northern Microgrid Fund. So in whatever initiatives are taken forward, could we drive this? One of the things that's a real issue in the microgrid solar community is there's really limited standards and expertise. So that's one of the challenges. It's actually an opportunity for perhaps the university, but also really in conjunction with the polytechnics, to try and enhance the level of skill that's out there, because it's not in the roofers playbook, and it's not in every electrician's playbook, and roofing is not in the most electricians' playbook. So you're dealing with, how do you know you're going to get something that's going to survive on your roof? That's something that perhaps there's a couple of things here where perhaps a third party would be able to assist with. If you do incentivize, and when I talk about incentivizing, right now, if a unit of microgrid energy is worth half of what a unit of energy is from the utility, maybe if you play along, you're part of supporting quantifiable benefits to the utility, maybe it's worth 75 cents instead of 50 cents on the dollar. Maybe that's a way to incentivize. There's ways that there are literally those schemes in, I think it's in the northeastern United States, I think it's Massachusetts, where the utility groups there have different rate structures depending on how much battery you have, as well as solar. So there's ways that can be structured. There's an opportunity, and this is where, as a involved in small scale solar and microgrids, my sense is that utilities can be polite, but they would just as well, you know, it's work for them. Well, maybe there's a potential public relations benefit, a marketing benefit, to actually embrace this community and encourage it in a way that does not add to their workload. That does raise another issue, which is, how do you manage you know, everyone who has a microgrid thinks they know how to run a utility. So if you're Sask Power, these are really annoying people. So how do you instead say, you know, we have to figure out a way to manage these people, but also not have them annoy us. So we have to find that way of managing turf. And again, I think that there are opportunities there, perhaps it could be a subsidiary of Sask Power, it could be another entity, it could be a voluntary group, but someone that they can use to carry the message, build us this, comply with this. We don't look at your systems. We're going to tell you, if you can do this, if you can allow us to give you an input that says, we want, how many kilowatts have you got available in storage, or how many kilowatt hours do you have available in storage? When can you dispatch it? Then you're worth something to us. And ultimately that could work us towards advancing a carbon neutral future. So I want to thank everyone for listening, putting up with my meandering, and I'd welcome questions. And then I guess there is also a plenary, and there's some discussion after, wherever they fit. Did I talk too long?
When does that happen?
Thank you.
Thank you, Doug. We'll cut you off then. So, yeah, we are running a little bit off our schedule. Yeah, our next, there are two speakers.
One question, maybe while I get.
Oh, yeah, maybe one question, sure. Any questions for Doug? Come on.
I'm afraid it'll be a long answer.
Yes, no? Okay, thank you, Doug. Right, our next, we have two speakers actually, both coming from Johnson Shoyoma Graduate School, huh?
One, Jason Prasky is Exa Energy.
Oh, okay. Well, one, the presenter from Johnson Shoyoma is Martin Boucher, right?
Yeah, and then, here, I'll get this mic going.
Yeah. Do you want to just do
Sure,
it?
sure. So we've got Jason Prasky here today, representing Saskatoon Solar Co-op. And we also have Martin Boucher here from Johnson Shoyama Graduate School of Public Policy. Now, I think, Jason, you're going to speak first. Does that make sense? That works? Okay.
Yeah, that way I get to take more time. So
Okay, so I'm gonna pin you so we can see you. So yeah, there's Jason. He's gonna roll without slides. Jason, actually on some side screens here, I can maybe put up your website so you can see the audience can see your website. But if you want to go ahead, and then we can all hear you. So please begin.
okay, appreciate it, Brett, and honored to be here. Don't get too many chances to speak to a group of well-informed people and passionate people about this opportunity, I guess, a problem to solve and opportunity with solutions here. And I really appreciate Doug's presentation. I logged in, I think, right towards the start, and I wish I had that much background and experience. What was the word? Actionable research. I don't have storage yet at my place, but solar and EVs for 10 or more years. So typically one-way power flow in either of those cases. I'm also a consultant. I think one of very few in the province, renewable energy consultants, and I'm able to give and take experiences and learning with the solar co-op here in Saskatoon to get as much done as we can. So I'll try and stick to 5 or 6 minutes here to give Martin a chance to speak and also to have a chance to answer some questions where we can. Basically, the solar co-op has always started with commercial sized projects. I think our smallest is partnering with the city of Saskatoon, about 13 kilowatts, and now all the way up to 400 kilowatts. With our last project, we were just shy of a megawatt of installed solar capacity. And it's a volunteer run board, a working board, so to speak. We'd love to be a bigger leader and educator in Saskatchewan on this. I think that I find sticking to the script here about kind of current state versus where further study may be needed. I think that's still where, as a province, we're lacking. I think we're probably most of you know we seem to be behind other provinces or states, whether it's small scale or large scale solar microgrids. My whole career, I spent 15 years at Sask Energy and seeing things like their provincial wide system and flow points coming in and customer flow going out and massive amounts of storage, in this case underground natural gas caverns. So I'm really excited about the storage opportunity on the electricity side that's really just coming up here and lots of different solutions for that. But all my career, I've been my challenge that I love is always finding the most economic way to do what we need to do to reduce emissions, in this case, to grow the green economy in Saskatchewan, et cetera, et cetera. Education as well. I admire all of Brett's and Martin's efforts in getting some of the research done and sharing that locally with Sask Power, et cetera. I think we need more of that, because I think I don't know how we do it, because again, most of my career I'm trying to do this. There's lots of I'll say us little people trying to get together and organize a bigger message, which is what we're doing today, and that's why I'm happy to be here. But I think that's where this slowly needs to go and is going. And Sask Power typically I found that it's been tough to, I'll say, bring them along because again, we all want to do things, but the utility needs to take care of the system as well. But they are, just last week, I noticed they've got some really good power talks, they're called, on YouTube. Some of you may have attended them live, but from small scale solar and storage all the way to the electrical infrastructure in North America. So they're helping us to see, what's being done in other places and how we could do things better and with their experience. So I think we can catch up fast is what I'm saying, but we need to all put our efforts together. And back to the microgrids again. I'm trying to find economic cases to promote to my clients and through the solar co-op as well. If there's a decent solid project that the solar co-op can earn revenue from for its members, for its shareholders, partnering with a building owner that could use the storage in an economic way. We're all looking for that. And again, back to SaskPower, Descharmes Lake, another YouTube video. They're getting some of SRC, Sask Research Council's help. Ryan Jansen is to me one of the smartest minds here with smaller scale renewable energy. They're helping out SaskPower to do a microgrid, cutting the power line way up at the end of the line at the Descharmes Lake, and so I'm excited to see progress there. It should be online next spring, I understand. So I hope that covers it, and I hope I can complement the rest of the talks here. I'll leave it at that.
Thanks, Jason. I'm just going to switch to Martin as the main speaker, but did you want to maybe describe your Case New Holland project?
Yeah, thanks. And good point. Since lots to say about that, but I'll try and keep it short. Luckily for the solar co-op and myself, just as the net metering program was getting tougher to do economically back in 2019, the solar co-op and my networks were like, well, can we do behind the meter where you don't need a SaskPower program? And the electrical code said yes. Everything I came across said yes, but no one I knew had done it before. So back in 2020, the solar co-op put up 400 kilowatts of solar behind the meter. So it all feeds into the plant there. They use between 3 megawatts down to 500 kilowatts of power at any given time, basically. So it was and they're a really great partner to work with. They wanted to do something like that, but just with their accounting policies and infrastructure, they couldn't. So a great relationship there. And within a week here, we've got a phase 2 of basically 400 more kilowatts tying in with C&H Industrial on 71st Street in Saskatoon, behind the meter again. So we'll have 800 kilowatts feeding their plant. And again, really excited to be a part of it, to learn from it, to have SaskPower make it work with us. And hopefully we can find, well, we're working on others around the province like that to get more solar going as fast as we can.
But thanks, Jason. So I'm gonna I'll maybe unpin you, Jason, for now, and I'll let Martin take the center stage here.
Okay.
There, are we good? How much time do I have, Brett?
You could do the presentation you planned.
1 minute. I know.
you got 10. Give you 10.
I'll try to be fast. I was busy cutting some slides just to make sure you can kind of go through your really exciting agenda. And I was really disappointed not being able to sort of be there with everybody today, but due to some car troubles and sick kids and things like that, I wasn't able to make it. But thank you so much for the invite, for being here, and I enjoyed Doug's presentation and Jason as always. So thank you so much. So I'm going to talk a bit of a different direction, less about the engineering, more about sort of scaling up and some work that I've been doing, supporting renewable energy, and or say that we've been doing. There's a group of folks that I'm working with on supporting both on the research side and some advocacy side on renewable energy cooperatives. So share a little bit of some of the motivation for that, some census work, do a little bit of a pitch on some of the reports and websites so you can dig further if that's interest to you, and then talk about some new research directions that actually might be aligned a little bit with some of the ideas that Doug was presenting in his work. So I'm not going to spend too much time on this, but just to, I think one of the things that I like to think about when I think about, the energy transition is that there's a question of scale and magnitude. Past transitions that we have had, and it's just sort of a reminder, because sometimes this is maybe lost in the conversation. They've typically taken about 50 years to really sort of have deep transitions. From the perspective of Sask Power, there's a strong motivation, and for good reason, to have affordable, safe, and convenient energy system, and that's typically what has happened with past transitions. And they usually involve significant social and economic reconfigurations. And the current transition isn't happening as fast as past transitions, despite all the pressure to do that. So this is like sort of starting off with a bad news story. I'm that annoying academic, but it really points to the need to accelerate and the need for scale, right? So there's a sense of urgency in terms of how we think about this, and how we think about renewable energy cooperatives sort of matters within this context. So what role do they play as we're really trying to scale things? So I think if we look at and this is just one quick way of thinking about it, the energy transition in Canada, if you look at our net zero, if we switch our grid, which is the plan to net zero by 2035, this is in fact going to be the largest, or one, if not the largest, infrastructure project in Canada's history, equivalent to the railroad that sort of made Canada Canada. So it's like that's the kind of magnitude of the thing we're kind of thinking about. So that's with renewable energy cooperatives. I think there's an important role, advancing climate change. That's a critical piece. But I think Doug alluded to this. There's also a question of social license, and that's often been a hang up with renewable energy, with all kinds of different energy. And involving communities in good ways, I think, is really, really critical. And I think that would be part of the pitch, I would say, with really trying to support, from a policy perspective, renewable energy cooperatives. So a few years ago, colleagues of mine, we got hired to do we got some funding to do a census on renewable energy cooperatives. We're really curious about, okay, what's the current state of renewable energy cooperatives across the country? And we did some work in that space. We learned that there's not a lot of information out there, so that's wonderful for researchers, because then there's an area which we can serve. So we did some sort of demographic work and interviews. All this sort of is available in the report, but to give you a bit of an overview, and this again speaks to a little bit of what Jason was talking about. Some of the things that we hear from folks. So we get excited about community energy. We get excited about folks in the renewable energy cooperative space. What we hear is stories of burnout, decline, stagnation of renewable energy cooperatives, despite all of this sort of excitement and motivation. There's varying levels of policy support, mostly not supportive. Most renewable energy cooperatives, and Jason knows this very well, and it's very much the case in Saskatchewan. They do some policy gymnastics and business gymnastics to sort of make their business models work, and that's very much the case all throughout the country, and certainly is the case here in Saskatchewan. And most of the, and then in some cases, Manitoba, Quebec, Newfoundland, there's very, very limited opportunity. And most of the co-ops in the country are sort of investment co-ops, which is the two, if we're talking Saskatchewan, those are the two though they're also investment co-ops. So you sort of buy a share, and you get some payouts as a member as part of that share. And this is just a bit of the sort of the development of co-ops. We had to separate Ontario, because Ontario is the sort of the big meatball of the renewable energy co-op story in Canada, particularly, again, talking about policies, the feed and tariff program. That was the big thing that supported renewable energy cooperatives in Ontario. And then when that went, so Ontario is the sort of blue here, when FIT went, the feed and tariff program, so too did a lot of the renewable energy cooperatives, and most of the future growth has been in other provinces. Saskatchewan, Alberta is a bit of a growth province. We're seeing a little bit more growth now in BC. So if you want a sneak peek, we have we have a whole map of all the renewable energy cooperatives, reports, videos, all the rest of it, to give you just a quick snapshot of the story. I think this sort of tells a lot. The last census was done in 2015. There's 89 renewable energy cooperatives across the country, and now there are 47 across the country. So that we've actually seen a bit of a decline. It's a rough story. Some of the co-ops have amalgamated or expanded and things like that, but it's sort of I would say in some, a bit of a story of stagnation, but a story of opportunity as well. And that's one of the things that we highlighted in our report that we did on renewable energy cooperatives that sort of discussed our findings. And one of the things that we heard from folks really across the country was we need opportunities to sort of support renewable energy cooperatives. And this is in the cooperative space generally. There have been approaches to support folks kind of doing their sort of wonderful community work. So there would be no different in the renewable energy cooperative space. And one of the things that we did, we called it the Rec League, is we organized an event in Ottawa where we actually brought leaders from across the country in the renewable energy cooperative space. We call it the Rec League. This is a call out to folks who are familiar with the cooperative sort of lingo and history. The league was sort of a bit of a was a beer conversation that turned into the conference title, but there's a history there. But anyways, as the Rec League, so we met in Ottawa with the intention of kind of forming a league, an association, a co-op of co-ops to sort of aggregate resources. So really to try to attend to this question of scale, right? So try to figure out where are the ways that we can support renewable energy cooperatives, kind of economize, create efficiencies, things like that across the country. And then also the other dimension too is sort of advocate, because from a policymaker's perspective, it's very, both at the provincial and federal level, it's very difficult supporting like all these communities across all the countries, across all the provinces. They want sort of like a single voice, to go to, perhaps a single entity to sort of to finance. And then that goes to renewable energy cooperatives. So it's kind of learning from the wisdom of what we've seen in other countries that have robust renewable energy cooperative space, and also the history of cooperatives in this country. So we've started the process of scaling. We've had our Rec League in Ottawa event in May. We have a steering committee of which I am the chair of. So we have a new name. It's called Community Energy Cooperatives Canada. We're going to be releasing a website really soon, pursuing aggressively funding applications to really make this thing a thing, and try to figure out ways to support renewable energy cooperatives, to both do the advocacy side, but also to support them in their business activities. As Jason was saying, the vast majority of renewable energy cooperatives, they're working boards. So these are people who have lives and jobs outside of being on a renewable energy cooperative, and then they're often volunteering their expertise, just like Jason, being very generous with this. He's an expert in energy, and then volunteering a lot of his time and energy supporting renewable energy cooperatives. So there's lots of although Jason is special, there's lots of Jasons across the country doing kind of similar work, and we're trying to we're culminating into a sort of a kickoff in Halifax that we have slated. We're going to bring folks together and have our have the co-op of co-ops sorted. So some of the things that we're trying to overcome, things like this is sort of the classic sort of co-op governance things, free rider problems. It's manageable if small, but as we scale, those are things to consider. Horizontal problems. How much do we prioritize short-term objectives over long-term objectives, especially in the context of urgency and accelerating? And then control problems, classic things like principal agent problems, sort of questions of governance. We've articulated some of these in a very recent paper we wrote for policy options. So feel free to take a look at that, where we talk about the tensions of scaling up. So really sort of thinking critically about like where co-ops are at and what this means for policymakers, and how policymakers potentially could support renewable energy cooperatives in a good way. So we go into that. And then I am an academic, so after all, so there are some future research, research projects that I'm working on right now that are funded by the Social Science and Humanities Research Council related to this, with co-ops and on the policy side. So one of the things we did was census work, and we sort of told the story of renewable energy cooperatives and kind of figured out, okay, what's going on, where are renewable energy cooperatives at in Canada, and then based on that, we're kind of flipping the script now and looking at policymakers and, okay, so what are the hangups when we, I know anecdotally so far when we speak to policymakers, certainly here in Saskatchewan, very sort of optimistic and positive about renewable energy cooperatives, but where are we kind of getting it wrong in terms of perhaps making policy changes, supporting these communities that are doing kind of really interesting work. One of the things that we have heard from renewable energy cooperatives are ideas around sort of virtual net metering. Perhaps that could be a tool to scale renewable energy cooperatives and then attend to some of the challenges faced by the utility. But this is sort of early days. We just sort of started this project. So we're going to be doing sort of comparative work again, sort of across the country, and tell the story from, in this case, from the policymaker side on virtual net metering, and kind of really kind of dig into what that looks like. These are some of the colleagues that I have on that project. So it's not just me. I'm cooperating amongst wonderful cooperators. And if you have any questions, feel free to, both on the research side and on this league, the Community Energy Cooperatives Canada, feel free to email me and be happy to take any questions or have a chat. Thank you very much.
Thanks, Martin. Yeah, if you could hear this applause in the room. Martin, can I just ask, could you go back to that slide where you show how things work and just maybe explain for the room what virtual net metering is and how that works versus the co-op?
Well, it'd still be a co-op. There'd be many different models. It would certainly depend on, one of the interesting things about, interesting from a research perspective, is that Canada has all these different utilities and utility structures. So from a researcher, you're like, ooh, this is excellent. There's so much learning we can do. But then from a policymaker's perspective, like, oh my gosh, this is bonkers. Everything's so different. So it matters sort of tremendously on that business model. But the idea would be there could be a few models. So this is something that's just sort of early stages. So and it would be renewable energy cooperatives could sort of have a site that they purchase a site, and they would have sort of, in this case, solar, wind, whatever it is, at scale, or some integration, a microgrid at a larger scale than they would otherwise have. And folks could participate through a net metering policy tool where there wouldn't be a requirement to have the solar panel on the roof. That so it opens up the sort of how folks can participate in renewable energy cooperatives. But this is just sort of early stages in terms of thinking about, and we really want to hear from utilities and policymakers in this space to really push us back on what are the sort of constraints, both technically, but also from how their grid operates.
Wait, thanks. And I'll just see any other questions for Martin or Jason. How are we doing? Any questions from Wascana Solar Co-op, who's in the house today? You're on. I think you're a dot on that map. Yeah.
Mm-hmm.
Well, I think we're seeing people feeling good and satisfied with what you just told us. We are going to take, I think, a break now then and come back and hear from SaskPower, and then I'm going to finish things off before we have a plenary discussion. So Jason and Martin, if you want to stick around and join the plenary discussion, that'd be great. But for now, thanks for being here. We'll give another round of applause.
Yeah, so now we're just going to take a 5-minute break, and then we have a couple of two speakers Our next two speakers are from Sask Power. We have Nathan and Corey. Before they speak, let me just introduce them. Nathan Huffart is a manager of customer solutions. He has led customer solutions at Sask Power, where a team is developing strategies to build and implement customer-facing products, programs, and services. Corey Gelowitz, who actually, as I said, spoke at the seminar just last week, is a project manager in grid modernization. He plays an integral role in developing Sask Power's long-term grid modernization strategy and roadmap. I also very much want to acknowledge Sask Power's help. We have their poster up, and they have actually helped us in terms of a little bit of funding, which we'll be paying for our pizza and beer later today. And again, I'm encouraging you to come. We have a lot of pizza. Beer, I think we can return if we don't drink it all. But with that, I'll hand it over to Sask Power.
Thank you. I'm just gonna hold this until I give it to you.
Try to put yourself in front of the camera.
It's my face here. So I got my nose. Let me see how this is going. Hey, good afternoon, everyone. I'm Nathan. I work in customer solutions at Sask Power. Corey and I are here. We're going to present, let you in on some of the things we're working on at Sask Power related to microgrids and some customer generation pieces. Oh, hang on. I'll try to stand in front of it. We're going to move quickly because I understand these are short time slots and we want to get through a lot of stuff. But we are going to cover what we've heard from customers in different sessions and stakeholders like this. Corey's going to talk a bit about some specifics on the distribution grid, some of the challenges with planning the distribution system, and he's going to go through a couple of pilot projects. An urban neighborhood sort of EV ready design pilot, a microgrid pilot that was alluded to earlier. And then I'm going to circle back and talk a bit about the customer solution space, customer programs and services, and the kind of things that we're thinking about as it relates to customer generation and microgrids and efficiency and all of those things. And I understand we'll likely take questions at the end or in some other portion of today. There we go. Okay, so what we've heard. This is an important piece because we get out to sort of the public with stakeholders and customers to listen to their inputs. There's continued interest and enthusiasm for customers to participate in the power system with Sask Power. But we see our customers' preferences changing. So there's an interest in more personalized experience compared to, a one-size-fits-all approach for everybody. In our recent Future Power Supply public engagement, again, someone was alluding to the power talks and some other things earlier. We found that there's positive association with encouraging individual choice, grid resilience, fair compensation, and decentralization of the power grid. So that's something we've heard from some customers kind of loud and clear. But we've also been cautioned to watch for inequities. And so it's important, as an example, for, say, customers in the north with a higher use of electricity, using electricity for heat. We're going to have higher electricity bills, that as we go through this sort of decarbonization, clean energy transition, that we consider the impacts and equitability and affordability for all customers, that we're not leaving any customers or any certain segments behind. Anyways, that all of this is going to require sort of a robust, modern distribution system that's capable of doing all the things we want the system to do, but balancing all the needs of the grid with all the expectations that our customers have for what that grid can do. I'm going to leave it at that, and I'm going to turn it over to my colleague Corey here, who's going to go through a few of these different pieces. You got to hit the page down button to switch.
Thanks, Nathan. All right, thanks for having us today. Appreciate you inviting us. Happy to be out here with the public and the university and forum group and to talk about our distribution system, microgrids, PV. Nathan and I are shoulder to shoulder. My role at Power is to make sure the grid is being developed and modernized in a way that can accommodate the things customers need. Nathan's role is to help design those programs and tell us what customers need. So he's really our customer. What do we need? What do they want? What are our customers looking to? And then we need to make that happen. So, and we can support the donuts and stuff after the coffee, not the beer. Being Sask Power, we can't support the beers. So I'm glad you have it. But okay, feel free to ask questions. if you have any. We haven't done a good job getting out and talking to the public from the distribution side. Our communications group's done a great job with the supply plan. That's happening for the last few years. Now it's distribution's turn. This is where all of you folks are connected to, is actually the distribution system. So here we are to talk, tell you openly what we can do, what we can't do today, and what we can do in the future and where we're headed. So please ask questions. Is my page down working? Excellent. Saskatchewan is geographically massive, right? 652,000 square kilometers. We serve all of it, except a small portion of the city of Saskatoon and Swift Current. So in the south, as we all know, prairie lands, flat, the north, forest, tough terrain. We have to serve every customer anywhere in that system. So we break it down more or less. We look at it from a distribution perspective. We look at it three types of customer areas or categories. Cities, high density, right? Small lots relative to the rest, rural, subdivision development. And with all this load growth, we have to develop subdivisions differently. EV load timing is a massive issue in urban areas. And there's small DG. Most people 5-7 kilowatts on the roof. So from our perspective, EV load and finding out how to keep infrastructure moving up with that EV load change is our biggest issue in the cities. Rural, very different beast. Long radial lines, meaning there's no redundancy, just long lines out to loads. Bigger customers. Farms are getting bigger and fewer. Oil field customers are large motor loads. Irrigation's growing dramatically in the province. Big motor loads, only used several months a year. And so it's really about rebuilding that infrastructure in an affordable way, just because there's just so much of it. And the timing of electrification, as opposed to the large impact, is when is it going to happen in the rural area? And large DG, right? Hundreds of kilowatts, 50s of kilowatts, farms can go bigger. And then the third area is the north, which has been spoken to as well. Indigenous communities, there's a lot of money coming into those Indigenous communities, which is great. But they're building water treatment plants and houses, and we need to get electricity to them. Long skinny lines in the north through the forest. We have huge vegetation management costs, and rebuilding those lines are massively expensive. So we've got to find economic ways to serve our Indigenous groups in the north. And they want to look at electric heat, a lot of them. So that's a concern. And often home builders up there are building, unfortunately, 2x4 stick construction, which is, for us, is a massive future liability for all of us. Whatever our rates, the costs that go into our rates, everybody helps pay for through rates. So any inefficient decisions just rolls back into rate base, right? So as a province, we have to figure out ways to keep things affordable. Microgrids are a key focus in the north, which has been spoken to. And I think, Doug, you brought that up. The north is where we're looking at microgrids. So we have 550,000 distribution customers, enough lines to circle the earth 3 times. And we're spending 3.5 million a week in investments in the distribution system. It's changing all the time. And most importantly, we serve 3 customers per kilometer line. Most other utilities serve 15, 20. NMAX is 62. I'm sure the city of Saskatoon's about 50. So that density, you're spreading the costs over more people. Saskatchewan, we have that issue of the costs have to be spread over less people. So we've got to do this right. And Nathan spoke to this a bit. How do we see the future? Electric vehicles are going to be a huge, everyone spoke to that. That's going to be a big lift for us. When, where, how much, what circuits out of our 3,500 circuits do we have to fix first or build first? How do we know that? Electric heating, when's that going to show up, in what way, how much electrical load across the whole system? We know we're going to have other parties, and that's fantastic. We need partners. We need third-party solution providers working with us. We're here to take care of the grid, the supply, but all these other aspects, really, we need to work as partners to say, what can you do with your customers? What sorts of things? We'll talk about how to interconnect that to the grid and make it work. We see solar and storage systems more so than just solar. We think storage is critical. And the grid in future, a few stages away, maybe in the more longer term, the grid will operate in real time and will control our assets and probably interact with customer assets. So it all runs autonomously in lockstep, minute by minute, making changes and adjusting. That's a future state. And we really see long-term that customer DG will be part of the supply plan. But in the short term, it's more of a, how do we accommodate it on the distribution system? Because we don't know where we need it or what the value is. So in the short term, we got to figure it out, and we are. In the long term, it'll become an asset that we can leverage into our whole plan. Today, however, DG is not a big part of our supply plan. It's just too small at this point, but we are watching it and accounting for it. I'm going to skim through this because I want to get to the DG microgrid side of things, but we are building our first EV ready subdivision. So instead of one transformer for 22 houses, we're looking at a transformer for every 2 or 4 houses. So it's just a whole different design, right? If you have an F-150 Lightning, they draw at 19 kilowatts. If you have Kia Soul, they might draw at 7 to 11 kilowatts. Your house right now probably peaks at 4 to 5 kilowatts. So that vehicle itself could be drawing at 3 times what your house is today. So if everybody does that, well, how big do we build the cable and how much is that going to cost? And when do we do it? It's going to happen everywhere, right? We don't know yet where it's going to happen. We're working on things to figure out and forecast where and when that's going to happen and what the impacts might be. How fast do we build? So our estimate in 2023, in 2035, we'll have about 142,000 EVs in Saskatchewan. A year later, make that 220,000. So that's about a 50% increase in our forecast for EVs. That acceleration curve is, the acceleration curve is accelerating. That makes sense. Engineers, or you can tell me if I said that wrong, but that's what's going on. So it's real. It's not here yet, I'll say the impact or the capacity constraints, but it's coming. This is what we see as annual sales as a percentage of all vehicles sold. We're at about 2%. 5 is a tipping point. 10 kind of through studies comes 6 years after you've hit 1%. Then 80% comes 6 years later. So that kind of follows our curve. That's vehicles sold, not total vehicles, but it all supports that curve. And what we see is that 26, 27 range, things on the system, spot for spot, could start to get tight. So we have to get ahead of that. Okay, microgrids, and I've got some things I'd like to speak about here, really in that DG space. And thanks to the previous speakers, a lot of the things you said, I'm nodding, and a lot of things you said we're doing, and right in stride with you folks. The Charm Lake is 96 kilometers north of La Loche, northwest part of the province. It's a fully Indigenous community, but it's not a registered or recognized First Nation. They are about a 30 kilowatt peaking community. Yeah, that's what they're drawing. Our line is old and needs to be rebuilt. It's going to be about $8 to $10 million to rebuild that line. Currently, we need to do about 1.8 million in veg management on the line. So our revenue out of that community is about 30,000 a year, and we have to spend about 10 million. So we will serve, we're here to serve the communities, but that's not a good economic equation. So what can we do differently? With that kind of cost comparison, we're putting in a microgrid, and we're working with Ryan Jansen of SRC and others at SRC. Ryan and I've worked together for a number of years, and we're going to install a solar battery diesel generator combination, right? So out of that combination, they've used their software and design to figure out that what's the optimum combination of those three. And there's the microgrid controller to decide how to manage the load over time, every minute of the day, every hour of the day, 24/7, 365, people want to use power. So the sun's only there when it's there. Battery, as Doug showed, will run out. So the diesels are there to make sure, fill in those gaps. So about 84% of the power we're forecasting will be renewable. However, even though we've oversized the solar by 7.5 times, even though we've oversized the battery by about 8 times, it's a 180 kilowatt battery, so about 5 times, and the diesel generators are oversized, the diesels don't fit into that equation. We still have to run diesels 5 months of the year. So you get that, you have to plan your capacity for the worst hour of the year, right? So there's no solar, there's no wind, and the batteries are done. What do? People still want power. We build reliable, predictable, available generation. Right now, that's natural gas, combined cycle plants, coal. What will it be? SMRs, CCS, natural gas, carbon sequestration. We're figuring those base load or those reliable solutions out. But right now, that's where we're at, right? And This really shows there's definitely a place for renewables, and we know that, and we're trying to figure out that whole equation. So Susan, we spoke quickly, these are the kinds of things we've got to solve is we have to serve every customer in the province every hour of the year. So how does solar fit into that equation? How does battery fit into that equation? There is no one silver bullet, as we all know. So these are the challenges that we face. And on the distribution system, we have to figure out these equations on every transformer. There's 180,000 transformers. Your bay is different than their bay is different than the oil field circuit is different than that northern circuit. They're all unique, right? So we need data. So this is what we're doing. We're currently distribution transformation, which I'm the portfolio manager for. Electrification is really driving our grid modernization and our grid hardening. We need, I think it was Wyatt who spoke to single one-way flow energy. We have to get to two-way. We have to see everything. We need two-way communications and we need two-way energy flows. So, but we need to see every device in real time. So we're putting out AMI meters. We're putting out smart technology on our substations and our lines. That's a huge infrastructure lift. You know, that's 550,000 meters. It's going to take us a few years, but we're moving. We're starting to get some data. We're starting to be able to make better decisions, but it's going to take some time. So in the interim, things we're looking at are, and this falls into more Nathan's court, load management things. What can we do with customers to say, could you start shifting off peak? Could you store some of that solar and drop it at peak, which is the supper time hour in winter? Right now, our price signals aren't there. Our price signals are, no matter when you use energy, it's 15 cents. That's a problem because that's not the real value. That's a legacy issue. So we have to get to a point where we can at least break that into a few blocks. How can you help us in this block overnight? How can you help us in this block during the day, solar? How can you help us in this block, 5 p.m. to 10 p.m.? Those are different questions, different solutions. So we're modernizing our grid. We're going to be using big data and real-time analytics to understand every circuit, every minute of every day of every year. And now we can start to, as Doug spoke to, in a perfect world, you'd be optimizing that in real time. That's where we hope to end up. So now DG, how does it fit into all that? As I've said, right now, we're trying to accommodate it. We're figuring out how to get into the system, what impacts it's having. Without data, we're just using modeling. Once we have real data, we can see what's happening. The Oasis site on the edge of the city, as Doug alluded to, we'll see it ramping up to 10 megawatts. Cloud goes over, it goes to 2. Cloud passes by, it's back at 10. Something has to replace that 8 megawatts, and that's our gas plants moving up and down to hit that. And our lines take that hit too. It's not just the supply, it's the lines and all those assets. The transformers tap down, they tap back up, right? So all that equipment takes that hit. I wanted to share a few other quick, how am I doing for time? 30 seconds? Nathan has to speak here too a bit. We have several other projects. Many other customers have, Lumsden, for example, on their wastewater treatment plant, they put a 500 kilowatt solar and a battery out there. And now they're learning, trying to figure out how that works. So outside of net metering, you can still hook up generation. We do have to do study. We study net metering to see the impact on the grid. We also study non-net metering. So the 100 kilowatts is more of that's a net metering commercial value. It's not a technical stumbling block. Technically, we can study anything and hook it up. So we will look at whatever solutions or renewable projects people want to do. It's just as you get bigger, it starts to trigger those bigger infrastructure protection systems, which is unfortunate. So we are really the grid looking out, and we want to provide information to you folks. Is here's the value to the grid, hour by hour, location by location, and that's what we want to get to. And so I guess we're asking for your patience and understanding that we get it. We're moving that way. We don't have all the answers yet. I don't know if we ever will. But we want to start that conversation and really let you know we're working on getting there. Here's how we see it from the grid. How do you see it from your side back in? So and let's get on the same side of the table, because this is a massive lift for the world, let alone Saskatchewan, and we all have to be pulling in the same direction on this stuff. So we have a lot of knowledgeable people about generation in the grid. And I think anything you can bring at us, we might not be the expert in your project, but we can tell you how it'll interact with the grid and what we have to do. So I'll turn it back to Nathan and
Yeah, and I've only got a slide here. or two, but I'm going to go back up one. But I'm interested in talking about sort of next steps and thinking about this is all exciting. Corey's talking about the stuff that happens on the distribution system and the way SaskPower is sort of transforming its system into a grid that can figure out a way to accommodate all these new technologies and all these things that different customers want to do. So I mentioned I lead our customer solutions team. We develop these customer facing programs and services with the goal of providing value to customers. That's our objective. What would provide value to our customers? An important component of that process is making sure we're collecting input and feedback and giving an opportunity for customers and stakeholders to contribute and participate in that process so that we're prioritizing and are directing our efforts at areas that actually provide value to customers. And it's a two-way relationship. So my team, Corey said, my group kind of represents customer interests along with some other groups, but customers have expectations. Different customers have different expectations. So that's an important consideration when SaskPower is trying to figure out how do the asks and expectations of this customer impact the asks and expectations of this customer. And while we're doing that, we're also trying to balance SaskPower's sort of business priorities and strategic imperatives as a crown utility with the obligation and opportunity to serve everybody in the province. So it's, I'm not up here sort of complaining, but it's complicated. And I think you all probably appreciate that. So to date, my team has primarily been focused on kind of three buckets of work or areas that we work on. Energy efficiency and affordability. With increasing costs, not just in the utility space, kind of across the board, affordability is an increasing issue for all customers, all customer segments. And so one of our top priorities is to figure out a way that we can help customers manage those costs. And one of the best ways to do that is to become more efficient or using less of your electricity. And one of the things that I'll say is that's also the most bang for your buck or the best way for you to reduce your costs. Not necessarily to install solar on your roof before you've kind of pursued those energy efficiency initiatives to try to get your demand or your draw as little as you can before you kind of take some of those next steps. So expect to see energy efficiency discounts in stores now. A plug for one of our programs. If you need smart thermostats or smart lighting controls or some specialty LED pieces, you can find those. But we'll continue to kind of roll those out the rest of the fall here and into the spring and into the new year in the coming years. One area I'm just going to touch on quickly is the EVs and electrification. Usually that's the part that most of the audience is most interested in. But today, given that we're kind of talking about customer generation, we'll gloss over that piece and you can come chat with me if you want to pick my brain about EVs and electrification and all those kind of pieces. But the last piece, customer distributed generation. So that's one of the areas that is maybe most complex or most difficult from a customer solutions perspective to try to figure out some solutions that work for everybody. Some customers want to generate their own power. Some customers want to purchase only zero emitting power. Some customers want to generate power and contribute to the supply plan and send it back to the grid. Some customers aren't interested in any of that. And so coming up with solutions that sort of check all those boxes and create the flexibility that different customers have and the different expectations that customers have is the hardest part. But I think one thing we know going through some lessons and things we've learned through net metering is that maybe a one size fits all approach isn't the most effective way to make sure that, we provide the flexibility for different customers to do the different things that they want to do and how they want to interact and work with SaskPower. One thing that I want to kind of close with here is that in the coming months, maybe into the new year, we expect to see and provide further opportunity for customers to contribute in the customer generation conversation. So I know maybe 12 months ago, we sort of started this conversation as it relates to net metering. And I know some of my team have been out talking about a shared renewables model. We've been sort of floating around there. But I want to make sure we provide opportunities for people like yourselves and other interested parties to help prioritize where we should focus and what we should be focusing our efforts on at SaskPower as it relates to customer generation. So even today, we heard all about virtual net metering and community energy co-ops and microgrids, net metering traditional, solar plus batteries. There's a lot of sort of segments that we can target and figure out how to come up with solutions. And so we're going to count on groups like this and people like all of you to help help direct us and say, this is the area we should start with. This is where we should start figuring things out. So I don't have any dates for you, but stay tuned, because this is an important step for, that my team, when we're thinking about what's next in customer generation, I think we've got to connect with all of you first and figure out what should be next in customer generation. And so with that, Corey, we appreciate you all for listening to us. Thank you very much. Yeah, we can take questions if you've got them. Oops.
Just wanted to check whether Saskatchewan is at the table, so ensure that estimates $2.6 billion years. Are you at the table, are you working with the feds to access that funding?
Holy smokes. It sounds like you're more current on that situation than I am. I think, and I guess you wanted me to repeat the question. It was about net zero commitments and, the cost to get to net zero, and, whether there's money available for provinces like Saskatchewan. I think what I know for Sask that all across Canada, we're a pretty diverse nation. And so there's different challenges and different jurisdictions and sort of different, positives and negatives to getting there. I believe, yes, we're at the table sort of sharing our concerns, trying to highlight what our challenges are, but I don't know anything more than that. I don't know. Do you have anything to?
Doug Opseth, he's our director of
Yes.
supply planning. He's out doing power talks, and that was a power talk that was delivered. So he's himself and another lady working for him would be the source for that. But the provincial government's talking with the feds, and SaskPower we're a crown corporation, with the provincial government. So we're kind of following that lead, but we're aware of all things possible and maybe not possible, but Doug could probably answer that more closely. Lara's here as our comms consultant, so we could follow up for you on that. But we're kind of at the micro level, Nathan and I, distribution side. So I see Jason, you have a question? Jason Praski?
Yeah, can everyone hear me?
We can
hear you.
Okay, yeah, thanks, gentlemen. Just a question, I guess for both of you, either of you, on when virtual net metering we might see as a pilot or a program. I was part of a pilot in Saskatoon here with Saskatoon Light and Power about 4 years ago, and I thought it went well. So there's some experience here now, but yeah, I wanted to hear what you had planned.
So virtual net metering, as I mentioned a couple minutes ago, is one of those areas that we hear about from different customers. To my knowledge, there aren't a ton of utilities, across North America that have implemented virtual net metering programs. However, as I said, this is one of those areas that we're looking at, saying how can we do more in that space and figure out what that might look like. So expect that to be sort of considered once we start to get these engagement initiatives kind of organized.
Yeah. And I think where I would be, maybe Nathan and I with a healthy tension, I would be pushing on him a little to say, whatever we do in the customer space, let's make sure that the grid can handle it and that we're making sure all ratepayers are being taken care of, and like any program we look at. So I think that's a conversation we need to have internally and with the public, is that anything we do, we need to consider the impacts it has on Saskatchewan, right? But I think the virtual net metering is certainly one of those topics we need to talk about, right? Yeah.
Thanks.
Okay. All right. Thank you.
Thank you.
Thanks so much. Okay, so our final speaker for the presentations is Brett Dalter. He's an assistant professor in the Department of Economics here at the University of Regina. Brett's research is focused on modeling the costs and consequences of climate and energy policy. Brett has been instrumental in helping to organize today's symposium also. So with that, I'll hand it over to Brett.
Thanks very much. I'm also the Zoom tech guy, so I mean, I hope this goes well, but if it's not going well online, maybe just raise your hand and let me know. So I'm gonna talk more about the policy side of things today. I'm really that's my focus. What's the cost of getting there? How do we make the economics work? What's the policy we put in place to make this happen? I'm going to talk a bit about some research I've done and then throw a few ideas out at the end. There we go. Okay, so I'm going to talk. One of the studies I've done recently looked at how that switch from net metering to net billing impacted the economics of solar in Regina, so specifically Regina. So I'll talk a bit about that. But then don't worry, SaskPower, you don't have to run away with your sign. I'm going to talk about why there might be that economic argument for why you'd explain why that happened. And then start to get into some ideas for the sort of no regrets solar policy we might be able to develop. And how can we make sure we start to drive the cost down on solar? So the study I wanted to start by talking about, we started with a survey, 2019 phone survey, 451 people. I don't know if anyone here got that phone call, but it was a random survey of people in Regina, landline, cell phone, and asked a few questions, some questions about, do you support the 100% renewable target? Found strong support for that, but then also started to ask some questions about solar, and specifically wanted to understand a bit more about whether people had, let me move my head here. Do people have roofs where you could install solar? In their own opinion, did they think they had that, where they could install solar, had a south-facing roof, not shaded by trees? Just over half of the people said that yes, they did. And if they said yes, they did, we'd ask them, would you be willing to install solar? If they said yes, what would you need to do that? Would you do it if you had to pay extra? Would you do it if you broke even? Or would you need a payback? And so, not a lot of people said they'd want to pay extra for it. Losing my buttons here. If they did say they'd be willing to pay extra, we asked them a random value. Okay, would you be willing to pay $40? If they said no, okay, how about 20? It kind of went up and down this payment ladder to see where they'd land. If they said they needed a financial return, again, ask them a random amount. If you got $10 back per month, would you install solar? No, okay. What about $20 a month? And so we kept doing that to get a sense of that net return people needed to get from solar in order to feel that they would install it. Put that all together, we have this look at how many of those households would adopt at different levels of return. So the positive numbers, this is the net solar cost, so it's kind of reversed. But if you have a positive number, you're actually paying extra for solar. Again, not many people in that boat, maybe 6% of people were willing to do that. Once you ask, break even, 27% of people would do it if they break even. And then once you get into the financial returns, you can, as the returns get higher, more and more people are willing to do it. So we had that data on whether people could install solar, how much they'd want to earn on a return. And then I worked with some engineers out of the University of Victoria to do some modeling of rooftops in Regina. So actually got GIS data for every rooftop, analyzed to see the slope of it, to see whether there was shading, and were able to calculate what's the solar output for every one of those roofs. And then we needed to understand, from a policy perspective, what kind of return could you expect to get? What could you get under the old net metering program? What do you get under the new program? I call it net billing, since I sort of think the net meter, it's not really, the meter's not really reversing anymore. You are, it's a credit on your bill that recognizes that you've sold solar to the grid. So what's the return on that? Now, to do that, you really need to have this smart meter data where you see the shape of people's consumption. You see when they're consuming, when that load happens. As we just heard, we don't have that for all of Saskatchewan yet. People at Corey are working to make that happen by putting the smart meters in. Saskatoon Light and Power does have that. So actually was able to get some of their data and match Saskatoon data with Regina rooftops to get a sense of what's their solar output going to look like. And so this is a typical kind of day where you'd see in the blue, what's load looking like? This looks a bit like Doug's load figures where, you know, it jumps up and down depending on if you turn on your dryer or your dishwasher, whatever it might be. And then your solar is going to generally have this this increase until, you know, you've got the sun right above you, assuming there's no clouds. Whenever you're generating excess, we know that that's when you're sending power back to Sask Power. And in the old net metering program, you would get the residential rate for that. Now you get that 7.5 cents a kilowatt hour. So just to give you a sense of how much would get sent back to the grid, a day like this, about 48% of it is self-consumption. So that's the house can use. And then anything that in this region here above the blue, you can kind of see that it's transparent. So you kind of see where you'd be sending power back to the grid. Just over half sent back to Sask Power. And of course, there's no solar available at night. So on this day, this household got 29.2 kilowatt hours of usage. Here's what they would have got based on their solar output and the old net metering. So they're offset $3 worth of costs because they've got that residential rate they're getting paid. They're getting paid that residential rate when they're self-consuming, so they're avoiding buying from Sask Power. But when they're selling to Sask Power, they're getting that 7.5 cents a kilowatt hour. So now you're down to, you know, from $3 to $2.23. So this is the kind of exercise we did to understand how much the economics would change going from the old to the new policy. This is just a look at, let's make this go away somehow, I don't know. There we go. This is a distribution. So of all of the households and rooftops we modeled, if there's more that end up in a certain monthly net return, you see monthly net return on the bottom x-axis. Hopefully you're all up to date on your graphing. X-axis there on the bottom. So if you're at $20, you can see it's a bit of a higher peak in that top ridge. So that means more of the households under net metering would have had that $20 monthly net return. But there's a bit of a taper there where some households could actually, you know, generate $40 or up to $60 monthly net return. Net billing starts to push that distribution back. So there's not those big returns anymore from solar, which is part of the what changed when the program changed. That last bit there, if you add in the Greener Homes grant, where you get some money up front for putting in solar, that actually starts to put things back to look like the old net metering because you've got that capital cost coming down due to that loan. So that actually helps in quite a significant way. I think it's interesting and good to hear the city of Regina is thinking about this PACE program, give low interest loans. That's going to also help homeowners, you know, finance that capital at a lower cost, make sure these projects can go ahead. So what do we find? What do we find for adoption with these different policies? With net metering, based on our survey, based on the rooftop data, you might have gotten 30% of households in Regina to put solar on their roofs. With the net billing, that's probably down to, well, our estimate's 23%. So you lose some. You're going from what would have been 94 megawatts to 74 megawatts, and what would have been 133 gigawatt hours a year to 105 gigawatt hours a year. So some capacity, but we're not going to meet all of Regina's electricity needs with that rooftop solar. This is an image from the city of Regina. They use 230 gigawatt hours per year for their own city operations. So if you put every, you know, what 30% of households had solar, you're meeting maybe, you know, half of what the city operations require. But to get all of the city's electricity needs, that's about 2,500 gigawatt hours a year. You're going to need a lot more renewable energy. And if you start to electrify vehicles and heat, you're going to need even more. So rooftop solar could have played a role, but it wasn't going to give us the whole package, at least just on residential. You heard from Wyatt, some of those commercial buildings or city buildings, you can put a lot more solar on. So that'll be necessary if we really want to up the renewable content in Regina. Okay, so why would we move away from that in this era of trying to reduce greenhouse gas emissions? My explanation from an economics point of view is, and we heard it from Sask Power, is part of it is the billing system that we have doesn't really reflect the structure of Sask Power's costs. And we need to think about what are these different costs related to generation. So in economics, we've got variable costs, things that change depending on how much you're generating. So if you're generating more with a natural gas plant, you use more fuel, you're paying more carbon pricing. You've got some operations and maintenance that you need to do more of as you run your plants more. So that's the variable O&M. You've got capacity costs, which you heard more about. That's Corey's area where he's got to size his lines and make sure the power system can meet the peak load at the biggest, darkest, coldest night in Regina. There's some cold night in December where everyone puts their turkeys in the ovens, I think, and puts the Christmas lights on. So 3,800 megawatts of peak load. And this is my analogy for it. It's kind of like similar to building a parking lot. If you got to build it for the Black Friday or Christmas shopping season when the parking lot's going to be full, even though most of the time the parking lot's not going to be full. So you got to oversize your systems right now with the way we've been doing things. So you've got to think about that peak is contributing to some of your costs. And then there's some fixed costs. Some of maybe the advertising, the billing, those don't change depending on the size of your system or how much energy you're generating. So those are held constant. But there are 3 different kinds of costs, and we're rolling a lot of them, most of them, into the residential rate, which indicates how much you pay per kilowatt hour. Looks like it's a variable cost because you use more, you pay more, but a lot of those demand or capacity costs are folded into that charge. I think I see some nodding in SaskPower. This is how you see the world too. It's too high. It's too high from how much you'd want to pay solar. It's also too high from what customers should be paying for that variable electricity. It's too high. Part of the what it disincentivizes is it disincentivizes electrifying vehicles and heating if you've got that high cents per kilowatt hour charge because it's not representing the true cost. Now you could change the billing system. I did some consultation actually with Martin and I back in 2017 to look at solar programs. One of the ideas that came up was to change the way you bill, actually separate out line by line. Here's how much it's going to cost for your transmission, your distribution. This may not be how you do it, Corey, but different parts of this, the demand charges get separated from the variable charges. You've got a peak capacity demand charge in there too. So industrial customers in Saskatchewan, they've got to pay a cost per kilowatt for how much they contribute to the peak demands, because that's how big you got to build your parking lot or how big you have to build your generation system. Households don't do that. You could move to that. And so that would give an incentive for the kinds of microgrids that Doug talked about, where if you're getting charged, if you're plugging in your Ford Lightning during peak hours, and you're going to have to pay a whole bunch now next year for your peak demand charge, that's going to incentivize you to put a timer on your EV charger or get a electric storage system set up so you can change when you're buying and selling power. If you do that, you're going to lower that variable volumetric charge, that cents per kilowatt hour charge. That's going to incentivize EVs. It's going to incentivize electric heat. I think it's better. It solves some of the problems. It does create that problem of, well, you're not going to pay much for solar if you're doing a net metering program. But we'll get to that in a second. We can maybe get to a no regrets solar policy there. So that's lower than the residential rates. If you're just talking avoided fuel from a gas plant, maybe that's 4 cents a kilowatt hour. Maybe it's higher now. Maybe it's 5 or 6 cents a kilowatt hour. It's lower than the retail rate anyway. So if you're generating solar, you're going to ramp down your gas plant, save some fuel. That's going to be worth less to SaskPower than that residential rate. So it makes sense why they didn't want to keep paying for that. But it's not just the fuel avoided. You got to think about the pollution avoided. So you can look at, as we put a price on pollution, carbon pricing is putting a price on a negative externality, as we call it in economics, of the impact of that pollution on our climate and the impact of those climate damages on all of us. So as you do that, you start to have that extra savings, which is that avoided pollution cost. We're at $65 a ton carbon price right now. The actual marginal damage cost of carbon is probably more like $250 a ton, according to the Government of Canada's estimates. So we're actually underpricing carbon right now. It should be $250 a ton, not $65. We'll get to $170 a ton by 2030. That adds 7 cents a kilowatt hour in terms of that avoided fuel and carbon charge. So we'd actually want to think about, well, you're avoiding the fuel and you're avoiding the pollution. There's a value to that avoided pollution. So that could be a basis for compensating people who are getting SaskPower to run those plants less. Now, as SaskPower gets cleaner, you're offsetting less and less emissions. So there's some race there between how fast the carbon price goes up and how clean SaskPower gets. But that's something to consider as we do the rate design. Now, we also should be striving to drive down the cost of that rooftop solar. we have an industry that sort of took off for a little bit, dipped down again. We can look to other jurisdictions to try to understand how do you drive down those rooftop solar costs. Australia, let me move myself again here. I don't know if you knew this, if anyone in the audience knew this, but about a third of rooftops in Australia have rooftop solar in place right now. It's total in Australia, they got 26 gigawatts of solar, 16.5 gigawatts on roofs. So a lot of their solar is on roofs, and they've driven the cost down. They were in Canadian equivalents over $5,000 a kilowatt in 2011. That's been driven down to close to 1,700 Canadian per kilowatt in 2020. So they've driven those costs down. Some of the studies looking at how they did it. One is you've got this market that's been consistent over time. So they've got a consistent policy, allows the suppliers, the installers to build up the experience, people to get more familiar with the technology. So I think who was mentioning that you need the roofer and the electrician both to have the right training to put this stuff in place and to be able to lower those costs. We think about some of that as the soft cost. The panels keep getting cheaper, but now we got to work on getting that installation cost down where suppliers they don't have to, maybe a future when we've got the grid modernized, they don't have to pay for an interconnection study. We know you can interconnect and you can get on the roof tomorrow if you give a phone call to the solar installer. You can do that in Australia now. So they've done that. So we can drive those costs down and hopefully make it so that those lines cross so that we can get, we've got net billing. I think it's set to be 7.5 cents a kilowatt hour till 2026. I'm sure it'll be reviewed then, but if we can get that cost of rooftop solar, the orange line, to get driven down, and we'll see that avoided savings for fuel and pollution is the blue line. That's going to keep going up. At some point they cross, and so at some point you could be giving a level of compensation that's going to give those net returns to the homeowners that we've surveyed in Regina, where they're going to want to do this kind of project again. So how do we do this? One idea, make sure as we review net billing, we start to line it up so it's both avoided fuel and it's avoided pollution. And so that net billing rate can go up as that avoided fuel and carbon cost goes up. Redesign the rates, probably easier said than done. I think people probably talk about that internal to SaskPower and external, but you could start to move things where you've got more fixed charges on your bill. It lowers your cents per kilowatt hour charge. So it's going to be cheaper for you to go and charge your vehicle. But you do have this big chunky fixed charge. One of the problems with having those chunky fixed charges, how am I doing for time? We're skipping the plenary. We're all going to go eat pizza. So my apologies for that. If you got these higher fixed costs, low income households end up having to pay more than they used to potentially if you change the rate billing approach. So why is that? Well, low income households generally using less electricity. It's another one of these kind of ridge plots, squiggly graphs. The first one at the bottom, number one, is the low income households. The x-axis here is how much they spend on electricity. Low income households generally, this is all the households we have data for in Saskatchewan, generally spending less. So the ridge is higher for those lower levels of spending. When you get up to higher income levels, you've got that ridge extending out to, it looks like mainly the highest point is $1,600 a year, but you've got people spending $2,000, $3,000 a year on electricity. They would have big savings by moving to that fixed charge and taking the volumetric charge down. So you can think about ways to make sure that doesn't get punitive for low-income households. What California has done is actually move to that system, the higher fixed charges, but make them means tested. So they've actually stepped up. If you're a low-income household, you have a lower fixed charge than the next tier, and you keep going up 5 different steps. Overall, the utility still gets the same revenue, but you collect it in a way that's means tested, so it's income tested, which means it's more progressive. It's going to be less of a burden on those low-income households. So that's a way to move to the right kind of rates incentive structure, but avoid hurting low-income people. If you do that, here's a chart looking at 2030 using some modeling data. This comes out of a study from the Canadian Climate Institute that I contributed to. The dark blue, how much average households spend by income quintile, again, that the 1, 2, 3, 4, 1 is the lowest income, 5 highest income groups. The dark blue, how much you'd spend per year on average with the usual rate design. If you put the means tested fixed charge in there, make it as progressive as your income tax system is, you can actually see that average expenditure drop for low-income households. That kind of lighter blue line is what you'd have with the means tested fixed charges. And you'd see that, yeah, the fifth quintile has a higher cost, but put it in perspective, look at the share of their expenditures as a share of their income. They're only paying 1% of their income on electricity. So a 10% increase for them isn't going to be as much of a hit as it is for the low income households where they're paying 2, 4, 6, 8% of their income for electricity. So it starts to deal with some of those affordability problems. Okay. How do we drive down the costs? Well, can we move towards more of an Australian model? We've got a long-term policy signal that keeps that solar industry going, that builds the experience. Can that help reduce the soft costs? Ideas to ponder. I don't know. Let's keep talking about it. One thing Australia has is the households can pre-sell their carbon credits. So they're getting the value for reducing pollution on the grid. They pre-sell those. That brings down the capital cost when they install their system. Again, incentivizes installation. I got one more. No, I'm gonna run out of the building after I show this last one. Maybe you break up Sask Power. Maybe you separate the distribution transmission from the generation side. Corey's the new CEO of Sask Grid. And Sask Grid, their job is to, they can earn a fixed rate of return on their capital investments. So they make the investments that we need. They modernize the grid. We mandate that Sask Grid to modernize the grid. We get the smart meters. We get the high capacities. We got EVs. We can do heat pumps. And we get to the point where we know we can pre-approve that anybody can install solar because we've modernized the grid. So we don't have any more connection studies, reduce those soft costs. So those are my ideas to ponder over pizza and beverages. I can take a couple questions. I think we've got just 5 minutes left here, unless I should run out the back door. But yeah, I will stop there. Any questions here or on Zoom? No, everybody's ready for pizza, I think. Hey, we could chat more also in the pizza room. All good. Okay, Robin, you want to?
Just some last words. The pizza is in CK 185 where we were last time. What we've actually done is we've tried to organize the tables, or I hope we have organized the tables into sort of more round tables. And we actually have a set of questions that we have put on each table. You don't have to talk about it. You can complain about the riders instead if that's what your preference is. But we actually also, I hope anyway, we'll have some students there who will be like note takers, so that we're going to try to collect whatever your thoughts are about some of those questions or anything else connected to topics that we talked about in today's symposium. We thank you so much for coming down for this event. CK 185 is just you go towards kinesiology, and it's the first door on the left there. We really do hope that you will all come because, as I say, we have pizza for 80 and we don't have 80 in the room. So thank you so much for coming, and thank you.
How do you switch this on?